Hello, so we are going to try to do this question, count the reversals. तो सबसे पहले तो इसे कॉपी कर लेते हैं हम. तो या लेट्स एग्जामिन द क्वेश्चन. तो कुछ चीज़ें जो खास है इस क्वेश्चन में वो ये हैं कि भाई पहले तो हमें ओपनिंग और क्लोजिंग कर्ली ब्रैकेट्स है, सिर्फ ओपनिंग और सिर्फ क्लोजिंग कर्ली ब्रैकेट्स है. मिनिमम नंबर ऑफ रिवर्सल्स निकालने हैं रिक्वायर्ड टू मेक अ बैलेंस्ड एक्सप्रेशन. अब बैलेंस्ड एक्सप्रेशन से इसका मतलब क्या है? अगर हम बात करें बैलेंस्ड एक्सप्रेशन की तो दो कंडीशन सेटिस्फाई होनी चाहिए. टू कंडीशंस शुड बी सेटिस्फाइड. टू कंडीशंस शुड बी सेटिस्फाइड. पहली तो ये आ जाती है कि जितने भी मतलब नंबर ऑफ ओपनिंग ब्रैकेट्स शुड बी इक्वल टू नंबर ऑफ क्लोजिंग ब्रैकेट्स. पहली कंडीशन. और दूसरी कंडीशन ये आ जाती है कि सीक्वेंस में होने चाहिए, मतलब ओपनिंग ब्रैकेट्स के बाद में आने चाहिए आपका क्लोजिंग ब्रैकेट्स. जितने हैं उतने, मतलब जितने ओपनिंग ब्रैकेट्स पहले आ रहे हैं उतने ही बाद में आने चाहिए. पैटर्न क्लोजिंग बेसिकली वो है. ये दो कंडीशन और कोई कंडीशन नहीं है. नाउ द थिंग अराइजेज इज कि भाई पॉइंट्स कुछ ऐसे केसेस टू बी वेरी ऑफ. ये सिंपल पॉइंट्स अगर हम कहें कि पहली बात तो ऑड जब भी होगा तो -1 नॉट पॉसिबल. और फॉर एवरी केस फर्स्ट करेक्टर should be a opening bracket, because if first character is not an opening bracket then we have to convert it. Okay, so basically this is the thing. And what else can we say? Yeah, so now if we think about the solution, say although I already know what the solution is, still I'll try to tell you how it is solved. Solution. See, the thing is, what we can do is after each and every opening bracket we need a closing bracket so that there is a sequence. I mean, as long as we are getting a closing bracket after an opening bracket, the brackets are balanced. So eventually we can remove such balanced brackets from our input string because they are already balanced and we don't have to do anything about them, neither reversing no nothing sort of anything. Okay, so what we can do is from this particular string that we have here, like let me take it here, just let me do it here only. See, the string that we have here is this and this. So yeah, so what we can do is we can clearly remove this part because this is balanced. Okay, so eventual string that we will have is of this sort. Now what we can do is, all we can think about is that the length of such string that we get after such an operation, let's call such operation or a function as p, or let's say balanced bracket removal. Okay, so after doing this operation balanced bracket removal, the string that we have is this. So now what we can think about is how can I now one thing is clearly sure, that if I can find the number of reversals required to convert this into some sort of the convert this arrangement of brackets into a balanced bracket form of arrangement, then I can know the number of reversals that I require. So the clear solution for this will be that we just split it in between. No, not even, yeah, kind of split it, you can say. No, actually we don't split it. What we do is we traverse through the string, and the condition is that for first few should be opening brackets and the rest should be closing brackets. Is that right? I don't think so, because if the test case is something sort of this is not possible. Because if it would be in this type of arrangement, then it would have already gotten included and included in portion of this, and this would have already been gone. So yeah, one thing for sure is that we will always get a after balanced bracket removal. There are only two conditions that we get: either the resulting string is empty, which implies that we don't need to perform any reversals, and the input string is itself in the balanced bracket form, or what we will get is a arrangement of brackets in the form something similar to this: some number of closing brackets, some number of closing brackets followed by a particular number of opening brackets. Now let's think about how can we make this balanced. One of the ways of making this balanced is one thing is for sure, that first one should be the opening one. First bracket should always be the opening one, because otherwise it's not possible. So if it is the opening one, then it's fine, we don't need to perform a reversal. If it is not the opening one, then we will have to perform one reversal. So we can say something like reversal counter. Okay, is one for now. Now for the second character. Now as we can clearly see that we have a opening bracket here, so this can both be a opening bracket and a closing bracket. What I mean by this is, if I have something like this, then this can be a opening bracket also and a closing bracket also. If this would be opening bracket, this will act as opening bracket for the next one. Or meaning is that we will leave it as it is. If it is an opening bracket, then we don't mind. If it is a closing bracket, then we don't mind. What we will keep in account is the number of opening brackets encountered, because we need to make sure is that number of opening brackets encountered till here is equal to the number of closing brackets that we encounter further. So now some may say that we reverse this one so that we don't have to reverse further, but the logic will be same, because if we reverse here and we don't reverse here, it would be same, because like we are reversing one extra here and leaving one extra there, so it will be equivalent. So what we can think of is, we can just clearly first define that number of opening brackets that we require are number of open brackets can be termed as the length of the string divided by 2. Let's say I name it as m. So m by 2 opening bracket should be there and m by 2 closing bracket should be there. Now there has to be arrangement that should be followed, which is that opening bracket should precede the closing brackets. So if there is opening bracket before a closing bracket, then it's fine. If there is not, then we need to perform some reversals. Did you get it? I hope you did. Okay, let me explain it further. See, the thing is, if there is a sequence, we will definitely get a sequence like this. There's no doubt about that. We'll definitely get a sequence like this. Now the problem that might be a bit changeable is like we might get a sequence sort of this or something like this. These are the only possible, like there may be many or there may be many here, but the arrangement will be something sort of this only. So now the problem arises is, should we just split it in half, change the ones that are there and not the ones that are there? No, that's not actually what I can say right answer or the optimal answer, you can say, because it won't give the minimum one, because there is a possibility like this possibility. Yeah, what we can do is just revert this one, which will make it like this, and then we have, oh sorry, we can make this one like, this is not working. We definitely need to change this one. How about this one? We leave it as it is. We change these two. Now this is equivalent to 3 reversals. Now let's assume that I didn't change this one. I changed this one also. So it was like this. I made this one like this. I keep this same and change this. So yeah, once again equivalent, not a very big thing. So the problem arises, is there a possible test case where if I change these ones it matters and not those ones? Let's see. Is it possible or not? I don't think it should matter. All that should matter is that I keep the ones here and not the ones there. Let's take an example like this. Sorry. Let's suppose that we put a arrangement like this after removal, balance bracket removal. We got something like this. Now our approach says that the thing that we are assuming as a possible solution is, we just split it in half, change these to something like this, and all of these, change all of these to this, the closing brackets into the opening ones, and the required ones to this. So like this remains same, and add it with green color, and the rest got reversed. So total reversed are 5. Now let's see if there was a possible better solution. What we could have done is, we could have changed this one, we could have left this one as it is, we could have changed this one, and need 3 opening brackets and 3 closing ones, right? And we could have left this one as it is. Okay, like 3 and 4, yeah. And then we could have changed here, left this one as it is. And changed this one. So the number of changes here are 3. So that makes all the difference in the world, right? This is the optimal answer, but this one is not. So that logic of ours to split it in between and then do it definitely fails. But this one doesn't. So what now? Now we need to put this into words. Put words like, we have described a process. Now we need to, implement it. We'll implement it later. First we have to, we have the logic how to solve the problem, but we don't know how to make it into a operation, like a function, so that we can clearly make the computer do it. If we don't analyze how to do it, then it's not possible. So let's see. What we did here was, if there is a possibility, if there is a, like, what will be the possibilities? Let me see. We can always change the last half part of the string. We always have that possibility. Like for example, let's suppose that I changed all these and these also. I mean, that's not a very good example. Let's see. Let's suppose the test case was something sort of this: 4, 5 and 6. Okay, now what we can do is, we'll definitely have to change this one, so we change this to this. Okay, now all the rest are like this. Let's suppose that I don't change this one, but I'll have to. There is no possibility. No, let's suppose that I don't see rest of these. So what I did was, I left this as it is, hoping that number of opening brackets what I require are 3, and up till now I have only encountered 1, so I got an extra one. I didn't have to perform a reversal here, so I saved one reversal, and I saved one reversal here also. Now I change the rest of the 3. I got 4 reversals by this method, and the gist of the method was that up till half I tried not to make any reversals as soon as it fits my as long as it fits my objective of keeping the brackets balanced. But as soon as I came to the half, I realized that I have to switch the like, as soon as I came to half of the string, I realized that I have gotten all the 3 opening brackets, so rest of the rest brackets I need to be closed, but I didn't get any closed, so I had to change them. That's the gist of the method, but there are some problems with this one also. What can they be? Can say something like number of characters left should be greater than or equal to number of opening traces. Is that a right statement or not? Let's see. Number of characters left should be greater than or equal to number of opening brackets. If we reach at a point where number of characters left become less than the number of opening brackets, then definitely it isn't possible, because now I can't change rest of the characters. So this should be a condition that should always be followed, that number of characters left are greater than or equal to number of opening brackets. Now, initially I'll try to save as much as possible. Initially we try to save our traversals. The gist of it is, for like, I know how many number of opening brackets I need. Okay, so if I'm getting an opening bracket and the total number of opening brackets hasn't exceed the number of closing brackets, then I keep it as it is. I don't reverse it. Okay, but there is a catch here. If I get an opening bracket and then a closing bracket. Then after that again a opening bracket. There will be some places where I'll be needing a closing bracket, I guess. I can eventually change them. What's the fault? No. No, there is a possibility. Let me give you an example. There is a possibility that I get something like this. Sorry. The kind of method that we'll be getting is something like this. Okay. No, definitely I'll be needing to change this one. Sorry. So I'll keep it as it is. I'll keep this one as it is too. Number of characters left are greater than or equal to number of opening brackets. Yes. Number of characters left. Okay, now what I do is I change the rest of them to closing brackets. Really not getting confused. This should work. Get the transformed string. If I'm getting a closing bracket, see, the problem will be in this test case. Suppose I'm getting something like this. Yeah. See, the problem here is I'll definitely have to change this one. Then this one. I can have a closing bracket, so yeah, no problem. Now I can't have a closing bracket here. The reason being that there should always be an opening bracket before a closing bracket. That is the only way we can keep it balanced. So what we can say is, let's say opening bracket, number of opening brackets before brackets prior. Initially it will be 0. Then if I get a opening bracket, then I'll just increment it. Now there is a condition that needs to be followed, which is that there should not be a closing bracket when there is no opening bracket. If str at I equals a closing bracket and number of I can just say and prior open brackets and prior open brackets, or you can say the lonely open brackets, lone open brackets are less than 0, or like less than 0, or is less than, no, they can't be less than 0, is equals 0, then I'll have to convert it. Like this, a situation like this is not possible, so I have to convert it. So what I'll do is I'll do reversal plus and lone open bracket plus. Also, if I encounter a closing bracket and lone open brackets, open brackets becomes greater than 0. Yeah, is greater than 0. Then I'll just do nothing, like reversals don't need to be, and this will just cancel out that one. So I'll just say lone open brackets, open bracket, minus minus, that's it. Now what if I get a opening bracket? If str at I is opening bracket, if str at I is a opening bracket and open bracket total is still less than what is allowed, then I'll do nothing, else if already gotten all open brackets, reversal plus lone open bracket plus minus. Will this work? That's the gist of the question. Now let me just code it. Let's say I get string find and m is equals to refined dot length. Okay. Now I'll traverse all of the array and lone open bracket 4 0 and else and open bracket encountered 0 okay, and allowed open brackets equals to 1 by 2. Now for int I is equals to 0, semicolon I should be less than n, semicolon I plus plus. If find I equals opening bracket and total open bracket encountered is less than, total brackets encountered is less than allowed, and then we keep keep this bracket and loan open bracket plus. Okay, now if this is not the case, this has already exceeded, else if and brackets encountered has become greater than or equals to allowed, then we won't allow these. We'll have to reverse, form a reversal, so therefore reversal plus one pair open brackets minus. Now else if defined at I equals a closing bracket and alone pair brackets somehow greater than 0, then we leave it as it is. Leave it as it is. Pair of brackets not balanced, so reversal will not be increases, but yeah, one pair bracket minus. Else if Control V, and the bracket is somehow equals 0. Then we will convert this into a reversal. Reversal and converted an opening bracket. So reversal plus one pair bracket and yeah, one more thing, whenever we do convert the opening to close, or whenever we get another opening bracket, we'll have to do open bracket tally plus, else if we do not do anything, bracket minus, else if this is bracket minus converted, and I think I fought somewhere, like if this was a Here it should be reverse. So see, less than allowed, then numpy bracket plus plus and open bracket tally plus plus 2. Yeah, I think it should work. Now the previous part of it that we have to code was, if we have gotten a string of that form and we have to remove the intermediate ones. Yeah. So what we can do here is we'll just use a stack, and whenever we have a last character as an opening bracket and current one and current character that we are on as a closed bracket, then we will assign it as this one, complete pair, and we'll remove both of them. So let's say we have a string input. Let's take an example so that we can formulate it quite easily and properly. So here we have something. And the rest of them are open brackets, 3 open brackets. Okay, so this is the string that we have. Now what we're going to do is we know this as a fact that we have to put the first character into the stack. So let's make a stack of character is that is a just check this up because I've forgotten how to, because it has slipped out of my mind how to initialize it. I'll check it when I'm coding. So yeah, s dot push inp and 0. Now we'll start with for int I is equals to 1 semicolon, I should be less than, let's say it has length n semicolon I plus plus. See, in the, let's say the good case if s dot top is equals an opening bracket and like input at I equals a closing bracket, and then we have found what we were looking for, and we have to remove this one, s dot pop, and that's it. Else what we'll do is we'll always append it. Like if this situation is not satisfied, then what we'll do is we'll just append, let's start push current on input at I. So will this work? Let's check it out. So first we had this one, s dot push, let's say stack last in first out. So first we had first we had this, and then we were at index 1, the last one is not this, so I pushed this one again here. For the second one, this condition is yet again, no, this condition is satisfied. I have got the opening bracket, but the current string which is here currently active is not the closing bracket. So again you just push it then we get a closing bracket, and the top one is an opening bracket. So this condition gets satisfied. Remove this one, spread pop. Then we go to this one, the next index, and we have once again have a closing bracket and opening bracket as the top. So we once again pop opening the last element of the stack. So this portion is now we have gotten an opening bracket. We have open bracket, so it gets pushed, it's pushed. So yeah, now we need to get the string. What we can do is simply just empty out the stack. No, we can take it as string refined while start empty, while stack is not empty, refined plus is equals to s dot top, then perform the pop operation, s dot pop. And as far as I know, I'll get the reverse string, something like this. We haven't designed our algorithm in reverse, so we'll just reverse the string. Find dot begin to, sorry, not the semicolon, column, refined dot end. So yeah, now let's go to coding, shall we? Yeah. Indexed. So yeah, we have gotten the input string. Now what we want to do is remove the balance bracket. Remove the intermediate balanced brackets. That we need a stack of characters. Let's name it as semicolon, s dot push input of C and first character or 0 index, character at 0 index of input. Let's make size input dot and the only condition, the good case, s dot top is opening bracket and current character that I is a closing bracket. And then we have to pop this element, nothing else. In all other cases, what we do is we just push time. Yeah, now let's just I need to empty string refined is equals to this. I think I can use some iterators to get the refined string. Let's just assume it. So while s dot empty refine plus equals to s dot top colon s dot top c now I've got a refined string. Now I need to get the answer. Not the answer, but yeah. So what are the parameters that I took? Don't have that in mind, so I'm just gonna check it. Yeah, string defined in temp is equals to refined dot length. Temp is equals to refined dot length. Yeah, I have to give count of non-open brackets before total open brackets encountered. Open brackets tally. So open bracket tally, and this one is open bracket previous allowed open brackets. This I don't actually need to do because this is embedded. So yeah, then I need all these conditions, bracket and all that. So let's get started. I needed previous one bracket is equals to 0 and open bracket tally equals 0. Now for I is equals 0 semicolon should be less than n semicolon I plus. Now first condition is the first condition, open bracket and what the open brackets encountered are less. First condition is we get front character is an open bracket and is a number of brackets encountered is less than allowed. In brackets tally is less than allowed on bracket. See, open equals an open bracket and bracket tally is less than should be less than because this will make it equal. It's less than m by 2. So to do this, we'll include it. bracket, tally plus plus. Brackets equal plus and brackets tally plus plus. तो greater का तो सवाल आना ही. There should be no question of being greater, because the thing is that if at all they are equal, then they should just, if they are equal, which will become here, there will be a time when this loop will execute, and after that they'll become equal. So this loop will not take equals and by 2. The new open brackets are not allowed. Yeah, form reversal plus plus lone pair bracket minus minus. Form because this has been converted into a closed bracket, then it will close our previous bracket. Yes, this is a closed bracket, and the number of open brackets, previous open brackets is greater than 0. So then we Now I really hope this one works, because I really have put, let's just check it, string input, scene input, equals to input dot length. Now we remove the intermediate balance bracket, stack characterize as dot push input dot 0, foreign tie is equals to 1, I should be less than 1, I plus plus. Good case, that is the one in which we get a pair start top equals start pop. Let's try this out. Okay, so there is some problem. Most probably as soon as happens when we try to access something that is not actually present. Let's just comment out a part of the code and see how much of it is working. Still not working. So we are getting a proper input. Yeah, there will most probably be a case when the stack is empty and I'm trying to, see. First thing that I should, good case, this should not be empty. Okay. Case possible stack is not empty. First out of is 41. This if stack is empty, then cannot do anything. We'll just have Let's see, is it the kind of string that we were looking for? No, we forgot to reverse it. Yeah. Three, 2 minus 1 and 1. 3, 1 minus 1 and 0. We are getting some inaccuracies. We are getting something wrong here. the problem is where? 3 1 minus 1 0. I guess we will just have to debug it by seeing where we are having a flaw. See out, put at I. Yeah, maybe what I can do is see out, put at I. Okay, and I'll just put a space. Now stack is not empty. If stack would have been empty, then stack is not empty. If stack is not empty, then I just pushed it inside. Okay. If stack is empty, then I'll print cout input at I just I input at I, and then ck stack is empty, filling with current. Okay, next line. So if this is not the case, then there are only two possibilities, which is, and I will just put here continue. Okay, this is not the case, then I'll print out put at I stack at I, and then stack space stack dot top. Okay, and there is not stack, there will be S, and saying if without else. The problem is that this will just cache it. So yeah, need to run this. Continue works like return statement, right? Now the problem is there are 3 brackets. There should be only 2. So where is the second one coming from? I stack is empty, filling with current. There are 2. What's the problem with this? Cout input at I, there are 2 input at I. Stack is empty, filling with current. Okay, I might have just Yeah. So let's see. Initially there was this one. Okay. Stack is empty, filling with current one. Then this becomes the last. Next one is this. This won't work. Just get the stack. Should I stop? Stop the stack. Okay. Now initially this went into the stack. Okay, now this cannot be. Therefore, just get the condition also. Oh. Stack empty if this then. Let's see now. Make it a bit smaller. Okay. Yeah. So initially we had this stack. Okay. Stack is empty. We filled this one, that one. Now we are at this current, and we get and the starting one is also opening bracket. Oh, I think there is some shit going on here. Yeah, I mean we have this one as current, this one as the previous one, so this also goes in here. Should have done it. This one is working. Let's check for the second test case. What is the problem? We still haven't been able to find the bug. So see, exam taken. So this is giving 1. The answer should be 1. Okay. What about this one? Three, 1 minus 1. It's working. Wow, magic. Earlier it wasn't working and I haven't even realized, but I guess I have cracked it. Now we need to get rid of cout statements. Recheck this if it's working. There is can anyone see now it's giving 1. Just now it was giving 0. I don't know what's happening. Did I leave any character or what? Sometimes programs can be so shitty. Okay, let me see. Okay, I'm doing solve. I have to find every integer here only. Let us just try one more thing here. Zero, 3, 2, minus 1. What's the problem with see what I did was string inp cn inp and 10 is equals to inp dot length and mod 2 is not equal to 0 cout minus 1 next line and returned the problem with this is with something like this one. As you might have seen, what all were the flaws in the program. Simple bugs. I wrote n in place of m, stuff like that. The good news is that our code, our logic was approximately right. Okay, now I just need to remove all the extra printing statements that I put to debug the program. Yeah. And I guess that's it. Okay, 3, 1, minus 1, 0. Plus no. Three, 1, minus 1 and 0. Let's submit. Yeah, finally. This actually was a good question, I would say, on this one. Yeah. So let's just stop.